Okay, everybody, we're back. This is section 5.5, and this is carrying on what we learned from before on counting. These are permutations and combinations, and I've watered down quite a bit of what I normally give on this, but I think we're going to hit everything that we need to hit. Okay, we're going to start with permutations. I'll do my exercise there, and then I'll do combinations, unlike what you have in the book. So, just so you know. First of all, a permutation, it's an arrangement of objects in a definite order. So let's say in this example here, we want to list all the permutations of this set. Okay, so obviously the three letters are A, B, and C. That would be a permutation. Okay, a different order, meaning a different permutation, would be ACB. I just put the letters in a different order. So that's two different permutations. When I switch the order, I come up with a new permutation. Now, those are two permutations where A came first. What if B came first? Well, then I could have had B with A and C. Or if B was first, I could have put C and then A. That's two more permutations. So I have two permutations with A first and two with B first. And if I continue the same logic, I could have C, A, B. I could have C, B, A. Each one of those is a different permutation. So how many are there? 6. Now, the whole point of what we're doing is I want to be able to count certain things. This is all part of a bigger thing called counting. And counting's not 1, 2, 3, and so on. It's the shortcuts that go with it. So what we're learning in this chapter is if I want to find out simply how many, there's shortcuts to do that. And I don't want to have to write them all out. So if you'll remember in the last lesson, I told you that we could do the lines. So a simple way to find out how many permutations there are without actually listing would be to say, okay, you're going to have 3 letters. How many choices do you have for the first letter? 3. Once you pick a letter to go there, how many are left for the next choice? 2. And once you pick one there, how many is left for the last one? 1. 3 times 2 times 1 is 6. And that's all you have to do. Now, in real life, here's an example of a permutation. Example 2 says, find the number of ways 6 people can arrange themselves for a picture if everyone's standing in a straight line. Okay, so just imagine, you got this straight line, you're going to line the people up. Here's person 1, person 2, 3, 4, 5, and 6. That'll be 6 people lined up. Just imagine the names underneath the people if you want to think of it that way. So how many different people could come first? Well, there's 6, so 6 altogether. Once you pick a person to come first, how many could come second? 5. And then 4. And then 3. And then 2. And then 1. And if you'll remember from what we did before, we could have written that as 6 factorial. And if we multiplied all those out, that's 720. Going back up here, this is actually 3 factorial, 3, 2, 1. When you start with a number and go all the way down to 1, you go down 1 each time till you get to 1, that's a factorial. Okay, let's look at example 3. This is kind of the same problems we had before, but now we only have 5 people. So 1, 2, 3, 4, 5. We got 5 choices for the first one, 4 for the second, 3, 2, 1. So really that's 5 factorial. And as you get good at this, you'll recognize that and just come up with the answer. And you come up with 120. Now, I'm going to show you something on the calculator. And I think this will show up. But let's say we want to do, let's let's say we want to do this one right here, that's 6 factorial. Okay, on your calculator, turn it on. Okay, so if I want to go 6 factorial, I go 6 and the math key. I'm going to hit math. And when you go across the top here, there's 4 choices. The last one is PRB, that's for probability. So I'm going to cursor over probability. And if you go down to your choices, you won't know what all these are, but number 4, see the exclamation? So if I hit 4, see how my screen says 6 factorial? I hit enter, and there's 720. Let's say I wanted to do this one. This was 5 factorial. So I simply put the 5 in there. Math. Cursor over. And then number 4. Enter. There's 120. Going back here, when I wanted 3 factorial, I'm going to go 3. Math. Cursor over. And you know, I could hit 4 or I could cursor down to the 4, either one. Either way it gets to you. And 3 factorial, I hit enter. And the answer is 6. So let the calculator do the work for you. Okay. More on that in a little bit. I'll come back to my calculator. Okay, so here's a different situation. And let's not look ahead. Let's stay with what we got right here. This says, how many ways can 6 people sit in 4 chairs arranged in a straight line? So just imagine you're only going to have 4 lines. There's 4 chairs. How many choices do you have for the first chair? 6. Then you're going to have 5. Then you're going to have 4. Then you're going to have 3. This is not a factorial. So what you'd have to do is take 6 times 5 and get 30, and 30 times 4 is 120, and times 3, that answer's going to be 360. Okay, so there's a different way of writing this. This is a permutation, but it's different than the other one. I could write this as a permutation of 6 objects, comma, and we just say picking, 6 picking 4. And that means the same thing as what we got up here. Okay, so let's jump ahead. Now, some books will write it like this with the subscripts. Our book will do it like this, so I'll try to stay that way. But when you have you say permutations of 4 picking 2. The 2 tells you got 2 blanks. The 4 says you start with a 4 and you go down 1 each time. So that's going to be 12. My next example, if I have permutations of 6 picking 3, that tells me I got 3 blanks. I start with a 6. I go down 1 each time and fill the blanks. 6 times 5 is 30. 30 times 4 is 120. If I had permutations of 8 picking 4, so I'm going to have 4 blanks. So 8, 7, 6, 5. I think that's 1,680, but let's put that in the calculator just to make sure. So 8 times 7 times 6 times 5. Yep, 1,680. Okay, so I showed you how to do factorials on the calculator. Okay, let me just copy these down. I'm going to do several examples here. So my first example, I had permutations of 6 picking 4. Then I had a permutation of 4 picking 2. permutation of 6 picking 3, and a permutation of 8 picking 4. So let's say I want to find the values. And I don't want to just write it blank. As a matter of fact, what if this was permutations of 100 picking 75? Do you want to write 75 out there? No. Okay, so let's just go down. I'll show you. So when you want to do the permutations, the first thing you got to do is put in the 6. Okay, now to get permutations, you go back here. You got your math key. So you go math. And we're going to cursor over to probability again. And if you go to the second one down, it says NPR. So that's that other form, but it's the same thing. But I want to hit number 2. And on my screen it says 6, then NPR. And my next number is a 4. And hit enter. So I get 360. Okay, let's do the next one. So I want permutations of 4 picking 2, so I put the 4 in first. Math, cursor over, second one down, and 2. So that's permutations of 4 picking 2. Enter. The answer is going to be 12. Permutations of 6 picking 3. So I put the 6 in first. Math. Cursor over. 2 for permutations. And I want 3 on this one. Enter. And I got 120. And then the last one I had here, permutation of 8 picking 4. So I'm going to go 8. Math. Cursor over. 2. Hit the 4. So it's permutation 8 picking 4. And I got 1680. So just out of curiosity, what if I said, let's go with a bigger one. Permutation of, how about 20 picking 7. I didn't want to get too big because my calculator wouldn't handle it. So on this one, we go 20, math, probability, 2, 7, enter. And you can see that number is 3, 9, 0, 7, 0, 0, 8, 0, 0. It's a big number. Oops. It'd be 390,700,800. But if you wrote that out, that would have been 20 times 19, because you're going to have 7 of these, right? 18, 17, 16, 15, 14. If you want to do that and then put them in a calculator, that's fine. I don't care. Now, let's just look at a really big one. I said a second ago, permutation of 100 picking 75. What's going to happen, that number is going to be too big for my calculator, but I'll show you anyway. So we go 100, math, probability, 2, 75, enter. Uh-oh. Interesting. Let's try it again. Okay. It's giving me an overflow error, and I know what it is. It's because my numbers are so big. By the time I multiply it, it doesn't fit in the calculator. So that's the problem. I really expected it to. I should have done the problem ahead of time, but I really expected it that it would come up to in scientific notation. So this is not the answer, but what we might have got is it might have said like 4.6735. And we would have known scientific notation, it might have been something like this. When they write it, it'll look something like this. Calculators are different, but a lot of times they'll go E13. The E means that's an exponent. And it's 10 to the 13th. So if you get something like that, that's what it is. Don't be surprised. Okay, so that was pretty good on permutations. Let's talk about combinations. Okay, combinations are a little bit different than permutations. If you'll remember, permutations are arrangements, which tells you that order is important. Okay, so ABC was different than ACB. Combinations are just groups. So these would be the same. Actually, all 6 of these are the same combination. So there's only one combination that you could put down. Okay, so combinations, it's the number of ways that you can group a number of objects together. Order is not important. So in my first example, it says, how many combinations are there using the letters A, B, C, D, picking 2 at a time? This is very similar to what we did with subsets. Remember how I paired the A with the B, A with the C, A with the D, then I went B with C, B with D, and then there's CD. So looks like there's going to be 6 of them. Now, unlike permutations, it's not quite as logical. You could either write them out like this, or you can use a formula. Okay, and similar to the permutation notation, we could write that as a combination of 4 picking 2. But here's the formula. Combination of n picking r. That means n is the first number, r is the second number. Whatever the first number is, you're going to put n factorial on top. Whatever r is, you're going to put r factorial on the bottom, but you're also going to put n minus r factorial on the bottom. So there's 2 numbers on the bottom, and everything's factorials. So let's look at this example here. That's what we had up here. It was a combination of 4 picking 2. I had 4 letters, and I was picking 2 at a time. 4 letters, picking 2. So a combination of 4 picking 2. According to the formula, it says whatever the first number is, that's the 4. It goes on top. I'm going to put 4 factorial. Then on the bottom, it says r factorial. R is 2, so I'm going to put 2 factorial. And the second part of that, and everybody forgets this for whatever reason, it's n minus 4. So using my numbers here, n was 4, r was 2, so it's 4 minus 2 factorial. Or I could write that as 4 factorial over 2 factorial, and 4 minus 2, that's 2 factorial. Okay, so continuing on. On top, that's like 4 times 3 times 2 times 1. On the bottom, I've got 2 factorial, so that's 2 times 1, times another 2 factorial, so that's 2 times 1. Now, 2 ways of doing this. On top, you got 4 times 3 times 2, so that's 12 times 2, that's going to be 24. And the bottom, 2 times 1 times 2 times 1 is 4. Looks like the answer is going to be 6, which is what I had right here, wasn't it? I had 6 of them. Now, another way of doing that, let me copy these numbers over here. It was 4, 3, 2, 1. On the bottom, it was 2, 1, 2, 1. Okay, first of all, the ones don't change anything. But you could look and say, okay, I got a 2 here and a 2 here. So these guys cancel each other out. And I got a 2 here that goes into 4 2 times. What's left? 2 times 3 is 6. All the ones drop out, and you end up with 6. Okay. Let's see, let me get my next page. Okay, so let's say that we wanted not all of my thing printed out. Okay. So let's say I had a combination of 5 picking 3. Using the formula, remember the formula was, I'll put it up here, n factorial, r factorial, n minus r factorial. So n is always the first one, r is the second one. So according to the formula, you're going to put the 5 on top, so that's 5 factorial. I'll just write it like this for right now. And on the bottom, okay, r is 3, so I got a 3 factorial. And then I'm going to have 5 minus 3, and whatever that is, I'm going to take factorial of that. So on top, I'm going to have 5. And let me write it as 5 factorial again. On the bottom, I'm going to have 3 factorial, and then 5 minus 3 is 2 factorial. So on top, I'm going to have 5, 4, 3, 2. I'm going to leave the 1 off because it doesn't change anything. On the bottom, I'm going to have 3, 2, 1, but I'm going to leave the 1 off. And then 2 factorial is 2 times 1. Again, I leave the 1 out. Okay, so that's going to be 20, 60, that's 120 over 12. Looks like the answer is going to be 10. Or, if you want to do this, this is what I would have done. I would have said those 2's cancel out. This 2 on the bottom goes into 4 twice, and that 3 cancels. So I got 5 times 2 on top. Nothing on the bottom, that's going to be 10. Or, let's use a calculator. Okay, so I'm going to put the 5 in first. Math, just like I did before. Cursor over. Same place. You'll notice number 3 is combinations. And 3, enter, and there's my 10. Let's do a couple of these. I don't have them written down here, but a combination of, how about 7 picking 4? I could do it this way up here, and I think you guys can figure that out, but I'm trying to show you the calculator. So we go 7, math, probability, we go to 3, put a 4 here, enter, 35. How about big numbers? What if I want a combination of 100 picking 5? 100 math combination 5, enter. It's a big number. 7, 5, 2, 8, 7, 5, 2, 0. 75,287,520. By the way, if I was going to write this out using the method up there, okay, so it would be 100 factorial. Can you imagine what 100 factorial? It's really a big number. On the bottom, we're going to have 5 factorial, and we're going to have 95 factorial. So if you didn't have access to a calculator and you wanted to do this, what you would do is you would go on top, it's 100 factorial, so that's 100 times 99 times 98 times 97 times 96 times 95, and that's going to go all the way to 1. So just pause on top for a second. On the bottom, we're going to have 5 factorial, so that's 5, 4, 3, 2, and remember, I'm not putting the ones down. And then what? 95 factorial. Isn't that what's still left on top? I wouldn't even write those down because what's going to happen, those are going to cancel. Then you could say 2 goes into 96 48 times. 3 goes into 99 33 times. 4 goes into 125 times, and then 5 goes into 25 5 times. So what that leaves you is 5 times 33 times 98 times 97 times 48. So if you multiply those out, let's see if we get the same answers. So I got 5 times 33 times 98 times 97 times 48. And I got that number right there, 75,287,520. So it did work out. Okay, there should have been one more on the example, so it did not print out, but I can do this one. This isn't too bad. So the question says, this is a real life problem. I don't know if you guys, how many of you guys play poker, but how many 5-card poker hands can be dealt from a standard deck of cards? And you should know this, but there's always 52 cards in a deck. Sorry, we ran out of space. Let's try. So how many 5-card poker hands can be dealt from a standard deck of cards? And there's 52 cards in a deck. Okay? So let's talk about that a second. Okay? This is a combination problem because it doesn't matter what order you get. Okay? Since order doesn't matter, it's a combination. So it's a combination of, how many cards do you have to choose from? 52. There's 52 cards in a deck. And how many are we choosing? 5 at a time. That's a combination of 52, picking 5. So let's just say I was going to do that. I'll use the calculator, 52, math, combination, picking 5 at a time, enter. And I got 2, 5, 9, 8, 9, 6, 0. So 2,598,960. So that's a good example of where you would use this. Sometimes they ask you questions. I'm going to kind of go off the grid here a little bit. We'll especially get into this with probability. But let's say we were talking about, okay, cards. Okay, just like the problem we were doing before. Things that you need to know. You need to know there's 52 cards in a deck. Now, some of you guys are going to say, well, everybody knows that. And unfortunately, that's not true. There's some people who don't play cards at all and really don't have any idea. But out of those 52 cards, there's what they call suits. There's 4 suits. Okay, there's diamonds. And on the card, it's got a little diamond. Okay, no special order here, but there's spades. And spades is kind of like an upside down heart, a little stem coming down. And there is hearts. And of course, a heart would be this shape. And then there's clubs. Clubs is like a clover. I'll mess this all up, but I don't know what that looks like, but that's kind of what clubs is. And then under each one of these, there's the ace, king, queen, jack, and then they go numbers. You got a 10, a 9, an 8, a 7, a 6, a 5, 4, 3, 2. And there is no 1. When you get into card games, sometimes the ace is 1, sometimes it's 11. But altogether, you've got 13 cards in each suit. So there's an ace of diamonds, an ace of hearts, an ace of spades, an ace of clubs, and the same thing all the way down. So if you got, 13 cards in each hand and you got 4 suits, if you take the 13 times 4, that gives you 52. 13, can't write, times 4 gives you 52. So sometimes that's important when they word these questions. And let's talk about this also. So if I was flipping a coin, what could happen? Well, you're going to have heads or tails. Okay, that's pretty simple. Okay, or what if you toss a die? What's a die? Well, die is singular for dice. You know the little cubes when you roll. So a die kind of looks like, see how good my drawing is. You might have a 1 here and maybe a 6 and a 3, and then there's a 2 and a 4 and whatever else I'm missing, a 5. Okay, so when you roll those, how many different things could come up? Well, you get a 1, a 2, a 3, a 4, a 5, or a 6. Now, these two things you probably don't need for permutations and combinations, but they do ask some questions here. As a matter of fact, I just gave you an example of that, so thought I would throw that in there. Okay, that should be enough, and believe it or not, that is really watered down from what I normally give on permutations and combinations. So with the questions you're going to have, I think you're going to find you should not have a problem getting these done. And I hope everything works out okay. And I will see you next time.